I want you to put yourself in a really specific environment for a second.
Okay, I'm ready.
So imagine you are walking through this dense, shaded, temperate forest in the eastern United States. It's early autumn.
Oh, nice.
Yeah, the air has that crisp, slightly damp quality. And the leaves on the oaks and the hickories, they're just starting to turn color. So you step off the main trail, you push through some brush, and suddenly you find yourself standing under a canopy of these small understory trees that they look completely out of place.
Right, they look like they belong in a jungle, not a temperate forest.
Exactly. They have these massive, drooping, almost tropical leaves that stretch like a foot long. And you reach up, you pull down a cluster of this greenish yellow fruit, peel back the skin, and you take a bite.
And that is the exact moment your brain just encounters a massive geographical contradiction.
Oh, completely.
Because the sensory input you're getting completely clashes with the woods around you.
Yeah, because what you are tasting is this wild hybrid of tropical flavors. It's like a seamless cross between a mango, a banana, and a pineapple.
But the texture is different.
Right. The texture isn't fibrous like a mango or watery like a pineapple. It's dense and rich. It's remarkably similar to a creamy vanilla custard. So your brain is screaming that you're standing in a rainforest in Costa Rica, but your feet are planted squarely in the woods of, like, Ohio or Virginia or southern Ontario.
Yeah, which is just wild to think about.
It is. You're eating the pawpaw, scientifically known as Asimina triloba. And the crazy thing is, it is the single largest edible fruit native to North America. It grows wild across 26 states.
26 states, and yet...
And yet, if you were to walk into your local supermarket right now, you would find absolutely no trace of it.
None.
Yeah.
It is a true phantom of the modern American produce aisle. And, that absence is exactly what we're focusing on today for this deep dive.
You got a lot of ground to cover.
We really do. We are pulling from an incredible stack of sources today. We've got botanical research out of Kentucky State University, some really fascinating historical pioneer accounts, permaculture agricultural guides, and the meticulous records of fruit breeders.
So our mission today is to essentially understand the life, the near death, and the complex resurrection of America's forgotten fruit.
Yeah, we're going to track the pawpaw's origins alongside ancient megafauna, explore its deep indigenous history, and look at the modern mad scientists trying to domesticate it.
Right, and we'll also dive into the genuinely eccentric biology of how it reproduces.
Oh, that part is so weird.
It's so weird. And perhaps most importantly for anyone listening who might want to actually go out and forage for this, we are going to uncover a surprising, highly dangerous paradox hidden right inside its sweet flesh.
It's really a biological story of stubbornness and survival.
Stubbornness is like the perfect word for it. The best way I can describe the pawpaw is by comparing it to an incredibly talented, fiercely independent indie rock band.
Okay, I like where this is going.
You know the type, right? They have this rabid, deeply devoted cult following. People will travel miles just to experience them. But commercially and biologically, the pawpaw absolutely refuses to sell out to the mainstream industrial agriculture machine.
Yeah, it just refuses to play by the rules of the global supply chain.
Exactly.
I really like that analogy because the pawpaw's refusal to sell out, it's not ideological. It is entirely physiological.
Right. It's literally built that way.
Exactly.
Yeah.
To understand why you can't buy this fruit at your local grocery store, we really have to look closely at the physical nature of the fruit itself.
Mm-hmm.
So when the fruit ripens, which is usually in September or October, the skin transitions from this soft, pale green to a yellowish hue that looks, honestly, almost bruised.
Yeah, they don't look super appetizing from the outside.
They don't, and they grow in these small clusters, somewhat resembling a stubby, bean-shaped hand of bananas, which is why locals often refer to it as the Indiana banana or the poor man's banana.
But the crucial factor here is what happens the exact moment it ripens, right? Because the supply chain for a modern grocery store is built on a very specific, unforgiving timeline.
Oh, absolutely.
I mean, think about it. A fruit is picked at a farm, it's sorted at a massive packing facility, loaded onto a refrigerated truck, driven across the country to a distribution warehouse, sent to a local store, arranged on a display shelf bought by you, the consumer, and then it sits on your kitchen counter for a few days before you even eat it.
Right, and that entire logistical ballet requires weeks of durability. I mean, the modern apple has been specifically bred for decades to have a thick, protective skin.
Yeah.
The Cavendish banana, the one we all eat, is picked rock hard and bright green.
Yeah, it only turns yellow through, like, chemical ripening once it actually reaches its destination.
Exactly. The pawpaw, on the other hand, has a wildly unforgiving shelf life.
Yeah.
Once you pick a ripe pawpaw from the tree or you pick it up from the forest floor, you have a maximum of about 3 days at room temperature before the flesh turns brown, mushy, and just largely unappealing.
3 days. I mean, 3 days destroys the entire commercial viability right there. You can't even get a truck out of the Midwest in 3 days, let alone manage the warehouse sorting and retail display.
You really can't. Plus, the skin is incredibly thin. It bruises if you just look at it wrong.
Yeah, so it definitely can't withstand the mechanical sorting or the rough packing.
Or the vibrations of long-distance shipping.
Yeah.
So as American agriculture evolved over the last century to prioritize standard, durable, globally shippable crops, the highly perishable pawpaw was fundamentally incompatible. It was just left in the woods because it literally didn't fit into a cardboard box on a delivery truck.
Which naturally leads to a massive question about its evolution, right? Because if we look at the pawpaw's family tree, it belongs to the Anaceae family, the custard apples.
Right.
And if you look at its relatives, like the soursop or the cherimoya, they are almost exclusively found in the deep tropics. They need heat. They absolutely cannot survive a freeze.
No, they would die instantly.
Right. Yet the pawpaw is hardy down to negative 20 degrees Fahrenheit. How on earth did a giant, tropical-tasting, fragile fruit end up thriving in the freezing temperate forests of North America?
It's a great question. And to understand that, we actually have to look far past modern agriculture, deep into the Pleistocene epoch.
Oh, wow. Going way back.
Way back. The pawpaw didn't evolve to sit on a supermarket shelf. It evolved its specific traits, its massive size, its heavy, nutrient-dense sweet flesh, and its remarkably large seeds to be consumed and dispersed by ancient megafauna.
Wait, we're talking about like the giants of the Ice Age.
Precisely. Animals like the giant ground sloth, which could stand upwards of 10 feet tall, or the American mastodon.
That is insane.
It is. The pawpaw tree grew in the understory, perfectly within reach of these massive foraging herbivores. So a giant ground sloth would come along and consume the fruit entirely whole.
Just gulp it down.
Yep. The animal's digestive system would strip away and absorb the soft, high-calorie pulp, but the large seeds were too tough to digest. So those seeds would pass safely through the digestive tract and be deposited miles away from the parent tree, conveniently encased in a massive pile of natural fertilizer.
I mean, that is a brilliant evolutionary strategy. You provide a delicious, high-calorie reward, and in exchange, a giant mammal acts as your personal long-distance transportation and fertilization service.
Exactly. It worked perfectly.
But those giant ground sloths went extinct roughly 10,000 years ago, and we just established that modern industrial farmers aren't planting them. So if the primary megafauna dispersers are dead, and humans largely abandoned them in the modern agricultural era, how is this tree actually thriving today? Because the sources say it's not endangered at all.
No, not at all.
It's aggressively conquering the forest understory right now.
It is, and the mechanism for its current survival involves this fascinating ecological irony. Right now, the pawpaw is thriving largely because of the white-tailed deer.
Wait, a deer is not a giant ground sloth? They can't swallow a fruit that large whole and pass the seeds?
Oh, they don't eat the fruit. In fact, they don't eat the tree at all.
Oh, really?
Yeah, so over the last century, human activity has largely eradicated apex predators like wolves and mountain lions from the eastern United States. And without those predators, the white-tailed deer population has just exploded.
Right, there are deer everywhere now.
Everywhere. And because they are so overpopulated, deer essentially dictate the architecture of the modern forest. They browse on almost every young sapling they can find, oaks, maples, hickories, but they absolutely detest the pawpaw.
Why? Is it like a textural thing or chemical defense?
It's entirely chemical. The leaves, twigs, and bark of the pawpaw tree contain these complex, highly unpalatable chemical compounds called annonaceous acetogenins.
Try saying that 3 times fast.
Right. But basically, these compounds taste terrible to deer, and they can induce severe digestive distress. So, a herd of deer will sweep through a section of the forest, systematically eating and killing all the competing oak and hickory saplings, and they will purposefully leave every single pawpaw seedling completely untouched.
That is incredible. So the overpopulated deer are acting like unintentional landscapers.
Well, that's exactly what they're doing.
They're weeding the forest floor specifically to benefit the pawpaw. The pawpaw just sits back, lets the deer eliminate all the competition for sunlight and soil nutrients, and then it just spreads out.
Exactly. And because pawpaws can spread through underground root suckers,
Yeah.
creating these vast clonal patches, they easily take over the cleared understory. But, while the deer are responsible for the tree's modern expansion, we really cannot skip over the critical thousands of years between the extinction of the megafauna and today.
Right, because there's a huge gap there.
A huge gap. The pawpaw didn't survive that gap alone. It relied on a completely different apex species for dispersal and cultivation.
Humans, indigenous peoples. I mean, the human element of this tree's survival is profound.
It's profound and it's heavily documented. Native American tribes across the eastern and midwestern United States didn't simply forage wildly for the pawpaw, they actively cultivated it.
Yeah, they were managing the landscape.
Exactly. They managed the forests, they planted the seeds along seasonal migration routes, and established these dense pawpaw groves near their settlements. It was an incredibly vital source of carbohydrates and vitamins.
Yeah, the sources we read show how deeply woven the fruit was into the fabric of daily life. The Shawnee people actually named an entire month on their calendar after the pawpaw.
Wow.
Yeah. And it wasn't just the fruit they used. The Cherokee harvested the tough, fibrous inner bark of the pawpaw tree to manufacture durable ropes and string, and they wove that string into fishing nets and carrying bags.
That's so resourceful. We also see brilliant engineering regarding food preservation. Because we talked earlier about the fruit's notoriously short shelf life of 3 days, right?
Right, the 3-day ticking clock.
Well, the Iroquois developed a method to circumvent this limitation. They would mash the ripe pawpaw pulp into small cakes and slowly dry them in the sun or over a fire.
Which changes the entire game. Now you have a lightweight, non-perishable, high-calorie food source.
Exactly. These dried pawpaw cakes became essential, lightweight provisions for long winter hunting trips when fresh food was scarce. When a hunter needed sustenance, they could simply drop a piece of the dried pawpaw cake into boiling water to rehydrate it into this rich, sweet sauce.
Oh, that sounds amazing.
Right. Or they would crush it up and mix it directly into cornmeal to bake fortified cornbread.
It's a perfect example of profound regional food sovereignty. But this brings us to a very somber reality in the history of the pawpaw, because that regional food system was violently disrupted.
It was heavily, violently disrupted. When we discuss the displacement of indigenous populations by European colonists, the narrative usually centers on the physical loss of land and territory. But what is often overlooked is the catastrophic biological displacement.
Yeah, the loss of the ecosystem itself.
Exactly. Being forced from your homeland also means being severed from the hyperlocal plants and animals that form the foundation of your diet, your medicine, and your culture.
If we look at the Lenape people, for instance, their ancestral homelands were centered in the mid-Atlantic region areas like present-day New Jersey, Delaware, and Pennsylvania. And in that region, the pawpaw, which they called machikbia, grew abundantly and was a massive staple of their diet.
But through a series of violent and coercive removals, the Lenape were pushed vast distances from that homeland. Many were forced westward into places like Oklahoma, while others were forced northward into areas of Ontario, Canada.
And neither of those places support the pawpaw.
Right. Both of those destinations represent entirely different ecological zones that are completely outside the native growing range of the pawpaw tree.
So not only are they losing their homes, they are suddenly in a landscape where their traditional nutrient-dense food sources simply do not exist.
And that biological severing created a forced reliance on government-issued food rations, which, these rations were systemically engineered for cheapness and shelf stability, not health.
Right, they were just calories.
Barely even good calories.
Yeah.
They consisted heavily of refined white flour, processed sugar, lard, and coffee, stripping away culturally significant foods like the pawpaw and replacing them with low-nutrition rations caused devastating multi-generational health crises within these communities.
Yeah, tragic.
It really is. Today, however, there is a powerful and growing movement focused on indigenous food sovereignty, seeking to reclaim and reintegrate traditional ancestral foods, including the pawpaw, back into community diets.
It is such a vital movement, and it really underscores how much history is literally grown in the soil around us. I mean, the European settlers who arrived and took that land also recognized the value of the pawpaw almost immediately.
Oh, they loved it.
Yeah, we have records showing George Washington was a massive fan. He reportedly loved eating chilled pawpaws for dessert at Mount Vernon.
That's a great image.
Thomas Jefferson, who was famously obsessed with botany, planted pawpaw seeds at Monticello.
And beyond the wealthy estates, the pawpaw was a genuine survival food for pioneers. In 1806, as the Lewis and Clark expedition was making its grueling return journey, their provisions ran dangerously low. The records show that for several days the crew avoided starvation by foraging heavily on wild pawpaws.
They literally survived on them.
They did, and much later during the economic devastation of the Great Depression, when rural families had absolutely no cash for groceries, the wild pawpaw patches in the woods provided critical, free nutrition.
So we have this fruit that was deeply cultivated by indigenous tribes, loved by the founding fathers, saved Lewis and Clark from starvation, and fed families during the Depression. It is completely woven into the DNA of the continent.
It really is.
But then it just fades into obscurity because of the modern grocery store supply chain. Which brings us to the obvious question. If it was forgotten by the mainstream, who took up the mantle to bring it back? Like, who is the champion for the pawpaw today?
That champion is a man named Neil Peterson. He is widely considered the pioneer of modern pawpaw cultivation. Some people call him the Johnny Appleseed of pawpaws, though he has playfully stated he prefers the title the Mahatma of pawpaws.
That's amazing.
Yeah. But to really understand his work, we actually have to jump back in time before Peterson was even born to a very specific historical mystery.
I love this part of the story from our deep dive. Set the scene for us. It's the early 20th century.
Okay, so it is 1916. The American Genetic Association decides they want to locate the absolute best wild pawpaw genetics in the country. At this time, agricultural contests were very popular for finding superior wild fruit variants. They announced a nationwide contest, offering a $50 cash prize to whoever could submit the best pawpaw.
And $50 was a significant sum in 1916.
Oh, it was a lot of money.
They must have been flooded with entries from every state where it grows.
They were. People mailed in boxes of fruit from all over the eastern seaboard and the Midwest. After careful evaluation, the judges awarded the prize to a Mrs. Frank Ketter from Ironton, Ohio.
Good for Mrs. Carter.
Right. Her submission won because her fruit exhibited the exact traits needed for commercial agriculture. The fruits were exceptionally large, they had a superb flavor, and crucially, they had a slightly thicker skin, which the judges noted could potentially allow for better transport to markets.
It sounds like the silver bullet. Like they found the perfect commercially viable pawpaw in 1916.
They did. But then history intervened. World War I escalated, shifting national priorities. The American agricultural system increasingly turned its focus toward mass-producing wheat, corn, and easily shippable fruits like apples.
So it just got left behind again.
Yeah, Mrs. Ketter's prize-winning pawpaw was entirely forgotten. The trail went completely cold, and those superior genetics seemingly vanished back into the wild.
Okay, so fast forward 60 years. It is 1976. Neil Peterson is a graduate student studying plant genetics at West Virginia University.
Yes, and he was leading a botany class through the university's arboretum. As they were walking, he caught a scent on the air. This sweet, heavy, tropical aroma that felt totally out of place in West Virginia.
Like a glitch in the Matrix.
Exactly. He followed the scent, found a pawpaw fruit resting on the ground under a tree, broke it open, and tasted it. He has described that exact moment as a profound epiphany.
He tastes it, realizes it tastes just as good as a mango or a melon, but it has never actually been domesticated.
Right. He understood instantly that the apples, oranges, and bananas we eat today, they're the result of millennia of selective breeding by humans. They look and taste nothing like their wild ancestors. But the wild pawpaw, with zero human intervention, was already incredible.
It was already at the finish line, basically.
Yeah. He realized that if someone applied rigorous, modern selective breeding to the pawpaw, they could create a world-class agricultural crop.
And he decides that he's going to be that someone. What fascinates me is his methodology here. He doesn't just go out into the woods and start planting random seeds. He approaches it like an investigative journalist or like an archaeologist.
Totally.
He knows about the 1916 contest. He knows that somewhere out there, superior genetics already exist, hidden on old family farms.
And his dedication was just absolute. Peterson spent his weekends, his vacations, and his sparse graduate student income driving down rural back roads across the Midwest and Appalachia. He was literally digging through dusty courthouse records, knocking on the doors of old farmhouses, trying to track down the surviving descendants of the farmers who had entered that 1916 contest.
Just looking for a genetic needle in a continental haystack.
Exactly. And in 1980, his treasure hunt finally pays off at a place called the Blandy Experimental Farm at the University of Virginia.
Oh, this is the best part.
It is. So the arboretum there had become somewhat overgrown and neglected over the decades. But as Peterson walked deep into the woods, his trained eye noticed an architectural anomaly. Trees in a wild forest grow randomly, right? They fight for light.
Right.
But Peterson found massive pawpaw trees growing in perfectly straight, parallel rows.
Which proves human intervention. Someone planted those intentionally.
Yes. He tasted the fruit from these specific rows and found it to be spectacular. The fruits were large, beautifully round, incredibly sweet, and they had a remarkably high ratio of flesh to seed. He strongly suspected he had stumbled upon a forgotten research plot containing the descendants of those early 20th century prize winners.
But he couldn't prove it initially, right?
No, the university's paper records were completely disorganized, so he couldn't prove it at the time.
But the proof did eventually surface, didn't it? Like decades later.
It did. In 2023, modern workers at the Blandy farm went into those exact woods using metal detectors. Buried under decades of leaf litter and topsoil, they found original stamped metal tags.
No way.
Yes. And those tags definitively proved that the trees Peterson had found were indeed the direct genetic descendants of Mrs. Ketter's 1916 award-winning fruits.
That gives me chills. It is literal buried treasure. So Peterson takes seeds and cuttings from these incredible historic trees, and he launches his own massive breeding program.
A breeding program that required immense patience. I mean, unlike annual crops like corn or tomatoes where you can see the result of a crossbreed in a few months, breeding fruit trees takes years.
Trees are slow.
Very slow. You cross 2 trees, plant the seed, and then you have to wait anywhere from 4 to 8 years for that seedling to mature enough to produce its first fruit. Only then can you evaluate if the genetics are actually an improvement.
And Peterson grew over 1,500 seedling trees across several decades. The financial and emotional risk involved is just staggering. I mean, in the year 2000, he took his entire life savings, bought a piece of farmland, and planted 3,000 pawpaw trees. He went all in.
He really did. And nature responded with absolute brutality. Within months of him planting that massive orchard, the region was struck by a historic drought, the worst recorded since the 1930s Dust Bowl era. Out of the 3,000 trees Peterson had poured his life into, 2,950 of them withered and died.
Oh, man, to lose almost everything after decades of work, I think most people would just walk away.
Oh, absolutely. He was financially ruined and emotionally devastated.
But Peterson didn't quit. He salvaged what he could from the survivors, continued his meticulous evaluations, and he eventually succeeded. He isolated a handful of truly superior elite pawpaw varieties.
He achieved his goal. He developed varieties that consistently produced massive, fleshy, sweet fruits with far fewer seeds. And, out of a deep sense of humility and reverence for the landscape, he refused to name them after himself.
Which is pretty rare in the fruit breeding world.
Very rare. Instead, he trademarked them and named them after great American rivers. So we have the Shenandoah, which is known for a smooth, mild, accessible flavor. The Susquehanna, which Peterson considers his masterpiece, known for being massive, firm, and incredibly buttery.
Sounds amazing.
And there are others, like the Wabash, the Potomac, the Allegheny, and the Rappahannock.
So if I am listening to this right now and I want a Susquehanna tree in my backyard, my first instinct is to buy a Susquehanna fruit, eat the custard, and just plant one of those big brown seeds in the dirt. Will that give me a Susquehanna tree?
No, it absolutely will not.
Bad out.
Not even close. And this introduces a fundamental rule of tree fruit agriculture. Pawpaws, much like apples, exhibit extreme genetic heterozygosity.
Okay, let's break that down. When you say they exhibit extreme genetic heterozygosity and they don't grow true to seed, you mean the child does not perfectly resemble the parent.
Exactly. If you plant a seed from a perfect, massive, sweet Susquehanna fruit, the resulting seedling will have a completely shuffled genetic deck. It might produce amazing fruit, but it is far more likely to revert to wilder genetics. It could produce tiny, bitter fruit that is 90% seed.
So how do you actually reproduce them then?
The only way to guarantee you're getting a Susquehanna is through physical cloning, specifically a technique called grafting.
Right, grafting.
Yeah, you must take a living cutting a small branch or bud, known as a scion, from a mature Susquehanna tree. You then take a random regular pawpaw seedling, cut off its top, and physically splice the Susquehanna branch onto the seedling's root system.
And they just fuse together.
Yeah, the vascular tissues heal together and the branch grows into a tree. Because the top of the tree is a literal clone of Peterson's original tree, it will produce identical Susquehanna fruit.
This is why Peterson had to license his trademarked varieties to specific nurseries. If you buy a named pawpaw variety online or at a garden center, you are buying a tree that has been painstakingly grafted by hand.
Yes. And the complexity of grafting is just the tip of the iceberg when it comes to the pawpaw's biology. The reason it took Peterson decades to breed these trees and the reason commercial agriculture struggles with them largely comes down to their incredibly bizarre reproductive system.
Okay, let's get into the weird biology. Because the pawpaw is a biological eccentric, the entire process of pollination seems designed to be as difficult as possible. Let's start with a term from our sources: protogynous dichogamy.
It sounds like a terrifying medical diagnosis, honestly, but it is a fascinating botanical mechanism.
Let's deduce this based on the roots of the word.
Right.
Proto means first, and genus clearly refers to the female anatomy. Dichogamy usually means things are happening at different times. So are you saying the flower is female first and then it physically changes?
You've hit the nail on the head. A single pawpaw flower operates sequentially, not simultaneously. When the flower first opens, it enters the female phase. The stigma, which is the part of the flower designed to catch pollen, is chemically receptive and sticky. However, during this exact same time window, the flower's own anthers, which produce the male pollen, are tightly closed and completely unripe. They shed absolutely zero pollen.
So functionally, the flower cannot pollinate itself because its own pollen isn't ready when its stigma is receptive.
Precisely. After a few days, a massive chemical shift occurs within the flower. The stigma dries up and completely stops being receptive. Only then do the anthers suddenly mature, burst open, and release their pollen into the air.
Wow.
Yeah, the flower has transitioned into a strictly male phase. Because the male and female phases never overlap in time within a single flower, self-pollination is physically impossible.
But wait, a mature tree has hundreds of flowers, all opening at slightly different times. Couldn't pollen from a male phase flower blow over to a female phase flower on the exact same tree?
It could, but the tree has a secondary defense mechanism.
Of course it does.
Pawpaws are strongly self-incompatible on a genetic level. If pollen lands on a receptive stigma, the flower chemically analyzes the DNA of that pollen. If it recognizes that the pollen shares its exact own DNA, meaning it came from anywhere on the same tree, it actively rejects it.
It just shuts it down.
Completely.
Okay.
The pollen tube will not grow, and no fruit will form. To produce a pawpaw fruit, you absolutely must have pollen delivered from a genetically distinct, completely different pawpaw tree.
The plant goes to extraordinary lengths to enforce cross-breeding and genetic diversity. But here is the massive problem, right? To get pollen from tree A over to tree B, you need an insect. And usually in agriculture, the entire system relies on bees. We rent millions of bee colonies to pollinate almond orchards and apple trees.
Yeah, but the pawpaw wants absolutely nothing to do with bees. And bees have absolutely no interest in the pawpaw.
Because the pawpaw is running a scam, it is essentially a botanical catfish.
That's a great way to put it.
Right. Most flowers attract bees by offering a sweet reward nectar and advertising it with bright, cheerful colors and pleasant, perfumed scents. The pawpaw flower is dark. It starts out a pale green and then matures into this deep, bruised, liver-colored maroon, and it does not smell sweet.
It smells foul. The flowers emit a fetid, yeasty odor that closely mimics the smell of fermenting, rotting fruit, or in some cases, literally decaying meat.
Why would a plant want to smell like garbage?
Because of the specific workforce it is trying to hire. Kentucky State University, which, by the way, operates the most advanced comprehensive pawpaw research program in the world, conducted a massive, rigorous study to figure out exactly what was pollinating these trees.
Because for a long time, people just didn't know.
They didn't. So over a period of 9 days during peak flowering, researchers set up sticky insect traps throughout an orchard and spent hours conducting direct visual observations of the flowers.
And they didn't find bees.
No bees. They conclusively proved that the primary pollinators are insects from the order Diptera, which encompasses various species of flies, gnats, and mosquitoes.
Mosquitoes.
Yeah. And the secondary pollinators are from the order Coleoptera beetles. Specifically, they found high numbers of lady beetles and click beetles. The researchers observed these beetles actively crawling deep inside the flowers, emerging completely dusted in pawpaw pollen.
So it's chemical mimicry. The flies and beetles are scavenging for rotting material to lay their eggs in or to feed on. The pawpaw flower mimics that exact scent, tricks the fly into landing and wandering around looking for the rotting meat, dusting them with pollen in the process, and then the fly gets frustrated, realizes there's no food, and flies to the next tree, transferring the pollen.
Exactly. The KSU study actually analyzed the scent profile and found it contains compounds like ethanol and acetone. These are the exact chemical byproducts of yeast fermentation.
Wow.
Furthermore, the researchers noted that the flowers emit the absolute highest concentration of these odors during their male phase, when they're actively shedding pollen, ensuring the flies are most attracted right when the pollen needs to be exported.
It is brilliant, but it is also highly inefficient. A honeybee is a systematic, dedicated pollen collector. A random forest fly is, well, erratic, because natural pollination by flies can be so spotty, you can have a massive, healthy tree that only produces 2 or 3 fruits, which means human growers have had to step in with some truly wild interventions.
This is where the folklore of pawpaw growing gets highly entertaining.
Oh, I found a story in the sources about an incredibly dedicated pawpaw enthusiast named Corwin Davis.
Yes, Corwin Davis.
He realized his trees weren't getting enough fly traffic, so to guarantee a heavy fruit harvest, he would literally go out to the highway, scrape up fresh roadkill dead raccoons, opossums, whatever he could find, bring it back to his orchard, and hang the rotting carcasses directly in the branches of his pawpaw trees.
It sounds viscerally disgusting, but from a purely ecological standpoint, Corwin Davis was a genius. If your plant's entire reproductive strategy relies on mimicking the scent of carrion to attract blowflies, what better way to ensure a massive swarm of blowflies than providing the actual carrion?
I mean, it works, but my neighbors would probably call the police if I hung a dead raccoon in my backyard.
Yeah, that might cause some zoning issues.
Fortunately, there is a less horrifying method for home growers. Neil Peterson and commercial orchardists rely heavily on manual hand pollination.
And hand pollination requires the precision of a surgeon. You cannot just shake the trees. A grower has to monitor the orchard closely, waiting for a warm, dry afternoon. First, you have to visually inspect the flowers to find one that has transitioned into the male phase, where the anthers look like a brown, dusty sponge. You carefully collect that pollen into a small container.
Then you walk over to a completely different, genetically distinct tree.
Correct. On that second tree, you hunt for a flower that is in the very early stages of the female phase. You are looking for stigmas that are bright green, plump, and physically glistening with receptivity. You take a highly flexible, incredibly soft artist's paintbrush, usually camel hair, dip it into your collected pollen, and gently paint the entire surface of the stigma.
But the environment is harsh. A rainstorm could wash that pollen right off before it fertilizes the ovary, or a clumsy beetle could knock it off.
Which is why Peterson goes one step further.
Yeah.
To protect his painstaking work, he purchases empty-size XXX pharmaceutical gelatin capsules, the kind you use to swallow powdered supplements.
Okay.
He dips the rim of the capsule into standard Elmer's craft glue, and he carefully slides the capsule over the pistils he just pollinated, gluing it directly to the base of the flower.
Wait, he builds a microscopic greenhouse inside the flower.
Exactly. It completely isolates and protects the fertilized pistils from the weather and other insects. And the beauty of it is, a few days later, when the flower naturally transitions into its male phase, the base of the flower sheds its old tissue, and the glued capsule simply falls off onto the ground harmlessly, leaving a perfectly fertilized embryo behind.
The level of dedication is staggering. But let's zoom out from the microscopic level to the macroscopic, because if you are listening to this and you think, I want to grow this, you are facing a daunting list of requirements.
Oh, it is a very demanding tree.
The tree needs shade when it's young, but sun when it's old. It has a delicate taproot. It needs moisture, but hates sitting in water. It requires genetically distinct pairs, and you have to attract flies to pollinate it. How do you design a physical space to accommodate all of these conflicting quirks?
The solution is found in a design philosophy called permaculture. Traditional industrial agriculture looks at a piece of land as a blank canvas to be bulldozed into a flat, sterile grid of monoculture rows. Permaculture looks at the land and attempts to design agricultural systems that mimic the diversity, the resilience, and the natural relationships found in wild ecosystems.
Let's break down how permaculture solves the specific paradoxes of the pawpaw. First up is the taproot. Pawpaws grow a very deep, sensitive central taproot. If you buy a seedling in a plastic pot from a nursery and you try to transplant it into dense, compacted backyard clay, the tree will often just go into shock and die.
Right. To mitigate transplant shock, permaculture experts emphasize extreme care in preparing the soil. Our sources suggest digging a hole significantly wider and deeper than the pot, and mixing the native soil heavily with vermiculite.
Vermiculite.
Yeah, it's a natural mineral that expands to create loose, airy pockets in the soil, allowing that delicate taproot to penetrate deeply without encountering resistance.
Then we have the light paradox. As we discussed, the pawpaw evolved in the understory of dense forests. If you take a one-year-old pawpaw seedling and plant it in the middle of a sunny lawn, the ultraviolet radiation will literally scorch the leaves, causing severe sunburn that can kill the plant. It absolutely requires a canopy of shade for the first 2 or 3 years of its life.
But the paradox is that once the tree is fully mature, if it is still stuck in the deep shade, it simply will not generate enough photosynthetic energy to produce a large yield of fruit. To get a heavy harvest, a mature tree needs nearly full sun.
So you have to plant them in the shade, but somehow guarantee they get full sun later. And then there is the water paradox. If you plant them low in a valley to ensure they get enough ground moisture, you run the massive risk that a late spring frost will settle in that low area and kill all the delicate flowers.
Exactly.
But if you plant them higher up on a hill where the cold air drains away, the soil might be too dry, or conversely, if the clay is too heavy, the water pools around the taproot and rots it. It feels like an unwinnable puzzle.
It does, until you apply a classic permaculture earthwork technique called swales on contour.
Walk me through what a swale actually is.
Okay, imagine a gentle hillside. When it rains heavily, the water sheets rapidly down the slope, eroding the topsoil and quickly leaving the hillside dry. A swale is essentially a shallow, perfectly level trench dug horizontally across the face of that slope, following the natural contour line of the hill. You take the dirt, you excavate from the trench, and mount it up on the downhill side to create a long, soft berm.
So you are basically building a massive speed bump for rainwater.
Exactly. When the rain falls and rushes down the hill, it hits the level trench and stops dead. The water pools in the basin. Instead of washing away, it has time to slowly and deeply sink down into the soil, recharging the local water table beneath the swale.
And this solves the water paradox for the pawpaw.
Yes. You plant the pawpaw trees on the soft berm just downhill of the trench. The deep taproot reaches down into that passively recharged subterranean water table, giving the tree constant access to moisture during the hot summer. But because the tree is elevated on berm, the top of the root system is never sitting in a stagnant, rotting swamp.
Another technique mentioned in our permaculture sources is the hugelkultur bed, which sounds like something out of a fantasy novel.
It's a great word. It is a centuries-old Germanic agricultural technique. Hugel translates roughly to mound or hill. Instead of burning or hauling away fallen trees, branches, and woody debris, you lay that wood on the ground in a line, and you mound massive amounts of soil directly over top of it.
What does burying a bunch of dead wood actually accomplish, though?
Over the years, that buried wood slowly decays. As it rots, it acts like an enormous underground sponge, capable of absorbing and holding incredible amounts of rainwater. Furthermore, the rotting wood becomes a haven for beneficial mycorrhizal fungi, which break down the nutrients and feed them directly to the plant roots.
Oh, that makes sense.
Yeah, the soil on the sides of a hugelkultur mound is naturally loose, aerated, and rich in organic matter, which is the absolute perfect environment for a pawpaw's sensitive taproot.
We can actually see all of these complex, interconnected ideas put into practice beautifully at a place called Integration Acres in southeastern Ohio. It's run by a farmer named Chris Chmiel, and he has taken pawpaw agroforestry to an entirely new level by integrating livestock. Specifically, he runs a flock of goats directly underneath his pawpaw orchard.
Now, integrating livestock with young fruit trees is usually a recipe for disaster.
Right. Anyone who has spent 5 minutes around a goat knows they are chaotic eaters. They will strip the bark off a young apple tree and eat every leaf in sight, killing the tree. So why is he putting goats in the orchard?
Because Chmiel understands the plant's chemical defenses. We talked earlier about how the right-tailed deer refuse to eat pawpaw leaves because of the ananaceous acetogenins. Those exact same chemical compounds make the pawpaw tree completely unpalatable to goats.
So the goats wander through the orchard, they take one sniff of a pawpaw tree, get repulsed, and ignore it. but they enthusiastically devour all the invasive weeds, the briars, and the aggressive multiflora rose that chokes the underbrush.
Yes. The goats are acting as a completely natural, fossil fuel-free landscaping crew. By clearing the underbrush, they make it vastly easier for humans to find and harvest the pawpaws when they drop to the ground in the fall. But the symbiosis goes even deeper. As the goats spend their days eating weeds under the trees, they are continually dropping manure.
Manure, which acts as a fantastic free nitrogen fertilizer for the soil.
It fertilizes the soil, yes. But crucially, think about what manure attracts. It attracts immense swarms of flies and dung beetles. Shmuel is using the goats to generate the exact biological workforce required to pollinate the pawpaw flowers blooming in the canopy above.
That is so smart.
It is a brilliantly designed, closed-loop ecological system.
He solves the fertilization, the weed control, and the bizarre pollination requirements, all with one flock of goats. And to solve the shade requirement for the young trees, the sources note he intentionally leaves native black locust trees standing in the orchard to provide a partial canopy.
The choice of the black locust is not accidental. The black locust is a leguminous tree, meaning it belongs to the legume family, like peas or beans. Legumes have a unique symbiotic relationship with specialized bacteria in their root nodules.
Okay, what do the bacteria do?
These bacteria can literally pull inert nitrogen gas out of the atmosphere and convert it, or fix it, into a solid, usable form in the soil. So the black locust provides the necessary shade to prevent the young pawpaws from sunburn, while simultaneously pumping free nitrogen fertilizer directly into the soil to feed them.
It's just spectacular. You aren't fighting nature with chemical fertilizers and pesticides. You are just arranging the natural puzzle pieces so they support each other.
Okay, so let's say a listener follows all this advice. They plant on a swale, they use hugelkultur, they successfully hand-pollinate, and come late September, they are rewarded with a massive harvest of these incredible custard-like fruits.
A great feeling.
But we know they have to eat them or process them quickly because of the 3-day shelf life. And this brings us to the final and most critical part of our deep dive. There is a deeply dangerous paradox hidden inside this fruit. If you do not process it correctly, you can get incredibly sick.
The processing aspect is vital. Because of the rapid decay, commercial processors who use the pulp for products like Pawpaw ice cream or craft Pawpaw beer rely on high-speed mechanical fruit pulpers. These machines, which can be single or double stage, use rapidly rotating paddles and specialized screens to violently and quickly separate the soft edible custard from the seeds and the skin.
And then they freeze it instantly, right? Exactly. The pulp is then instantly frozen. For a home user, the safest method of preservation is manually pressing the pulp through a colander and freezing it in bags.
Yeah.
You cannot just throw the whole fruit in the freezer. And more importantly, you must be incredibly careful about what parts of the fruit you consume.
I've heard whispers in foraging circles that there is a dark side to this fruit. Something about people getting violently ill if they try to preserve it using certain common methods, like making fruit leather.
Those whispers are entirely accurate, and they revolve around a very specific, terrifying case study involving Dr. Bill Schindler. Dr. Schindler is a highly respected anthropologist, a primitive technology expert, and an incredibly experienced forager who really understands wild foods.
So he's not a novice.
Not at all. He had been safely foraging and eating fresh pawpaws for years. But one autumn, he decided to experiment with preservation. He took a batch of fresh pawpaw pulp, spread it out on a tray, and put it in a dehydrator to make homemade fruit leather.
Which sounds completely logical. I mean, people make apple leather and strawberry leather all the time.
It makes sense intuitively, but chemically, it was a disaster. Once the dehydration process was finished, Dr. Schindler and his young son tasted the final product. They ate a minuscule amount, a piece of fruit leather, roughly a quarter of an inch square, less than the size of a postage stamp.
And what happened?
Within an hour, they were both struck by explosive, violent gastrointestinal illness, severe vomiting, debilitating stomach cramps, and intense, throbbing neurological headaches. They experienced acute poisoning.
From a quarter-inch piece of fruit, what exactly poisoned them?
They were poisoned by the exact same class of chemical compounds that keep the deer and the goats away from the leaves, the ananaceous acetogenins, specifically a highly potent neurotoxin called anonicin. In the pawpaw fruit, this neurotoxin is heavily concentrated in the dark brown seeds and in the skin. But crucially, it is also highly concentrated in the unripe flesh of the fruit.
Wait, if the toxin is in the fruit, why do people eat fresh pawpaws all the time without getting violently sick?
Because as the fruit fully ripens, the chemical composition changes, and the concentration of anonicin in the edible pulp drops to trace amounts. A healthy human body can process and eliminate those trace amounts without immediate distress.
Okay, that makes sense.
However, it is worth noting that in tropical regions where related fruits like the soursop, which also contains an anisin, are consumed in massive quantities daily, chronic, long-term exposure to the neurotoxin has been clinically linked to atypical Parkinsonism, a severe neurological decline.
Wow. Okay, so if the fresh ripe pulp only has trace amounts, why did Dr. Schindler and his son end up severely poisoned from a microscopic piece of fruit leather?
Because of the mathematics of dehydration.
Let me think through the mechanics of this. When you put fruit in a dehydrator, you aren't removing any of the physical matter or the chemicals. You are exclusively evaporating the water. A fresh pawpaw is mostly water, so if you take a cup of wet pulp, it has a certain safe trace amount of the toxin. When you dehydrate it, the water disappears, shrinking that cup of pulp down to a tiny, dense strip of leather. But 100% of the toxin remains.
Precisely. By removing the water volume, Dr. Schindler unintentionally hyperconcentrated the trace amounts of the neurotoxin. A tiny bite of the dehydrated leather contained the chemical equivalent of eating an enormous, physically impossible volume of fresh pulp all at once. The dose makes the poison, and he inadvertently manufactured a highly concentrated neurotoxin pill.
That is terrifying. Which establishes the absolute golden rules for anyone foraging this fruit. You must never eat the skin. You must never consume or break the seeds, meaning you can't just toss a whole pawpaw into a blender, because if the blade shatters a seed, you are dispersing neurotoxins directly into your smoothie. And you must never cook or dehydrate the flesh. It is eaten fresh or it is frozen.
Those rules are absolutely non-negotiable.
But looking at this logically, why would a plant evolve to put a dangerous neurotoxin inside a fruit that tastes like vanilla custard? That feels like an evolutionary contradiction. Why make it delicious but poisonous?
It is not a contradiction at all. It is the ultimate evolutionary lesson. As humans, we suffer from an immense biological hubris. We wander through the woods or the supermarket, and we subconsciously believe that fruit exists as a gift from nature to us. We think the apple exists for our enjoyment.
But the plant doesn't care about us at all.
Exactly. The fruit does not exist to serve the human. The fruit exists exclusively to serve the plant. Its sole biological purpose is to ensure the survival, protection, and eventual dispersal of the plant's genetic offspring, the seeds.
Right. The plant wants an animal to carry the seeds away.
Yes, but only when the timing is perfect. While a fruit is developing on the branch, the seeds inside are soft, immature, and incapable of surviving digestion or germinating in the soil. If a hungry animal eats the fruit at this stage, the seeds are destroyed, and the plant has failed to reproduce.
Ah, I see.
Therefore, the plant intentionally pumps the unripe flesh full of bitter, toxic, and harsh chemical compounds like anisin. It is broadcasting a clear chemical warning to the forest. Do not eat this yet, it will make you violently ill.
But once those seeds finally mature and their hard protective coats are fully formed and ready to survive an animal's digestive tract, the plant flips a switch.
It undergoes a massive metabolic shift. The plant systematically breaks down the toxic defenses in the pulp, converts complex starches into highly appealing, easily digestible sugars, softens the cellular structure, and begins emitting those volatile, sweet aromas. It is changing its message from "stay away" to "the seeds are ready and protected. Come eat this high-calorie reward and transport my offspring to a new location."
So the pawpaw is basically negotiating with the animal kingdom. It says, the custard is your payment, but do not itch the skin and leave the seeds completely intact. It is a perfectly calibrated, ruthlessly efficient survival mechanism.
It is a masterclass in botanical adaptation. When you trace the entire narrative, the pawpaw is a species that evolved alongside massive Ice Age beasts, survived their total extinction by embedding itself into the agricultural networks of indigenous human populations, developed complex neurotoxins to defend its foliage from overpopulated deer, orchestrated an elaborate chemical deception to trick scavenging flies into pollinating it, and nearly vanished from the modern world entirely simply because its biology refused to conform to the standardized shipping logistics of a modern supermarket.
And now, thanks to the obsessive, decades-long work of breeders like Neil Peterson and the creative ecological problem-solving of permaculture farmers, it is slowly clawing its way back into the light. It is a wildly complex, somewhat dangerous, completely delicious phantom of a fruit.
It serves as a powerful reminder of the resilience of wild ecology and the often fragile complexity of our historical food systems. It forces anyone who interacts with it to slow down, to eat hyperlocally, and to respect the plant's biological boundaries.
The fact that something so spectacular was almost entirely erased from the modern American palate, just because it couldn't survive 3 days in a cardboard box on a refrigerated truck, is staggering.
Ah,
It makes you wonder what else we have sacrificed for the sake of convenience. What other incredible flavors have we paved over or forgotten?
that's a great question.
So we want to leave you with a final challenge. Sometime this week, look out your own window, or take a walk through the woods near your house, or even just look at the weeds growing at the edge of a local park. What other ancient, hyperlocal, incredible foods, medicines, or natural wonders are sitting right there in your own backyard, just waiting for you to remember they exist?